sebab I think I better leave you doing your own work better daripada I cerita lebih. Tapi I nak recap. Okay. Recap apa yang kita perlu buat, apa yang you perlu buat. Okay. So hari ni punya discussion saya tak record lah. Meaning that it will be tak ada reference lah after this. Okay. But you need to be here. Okay, so saya akan present entire screen. Okay. Kita tengok balik kita you punya mini project. Okay. So there is a growing need for the Malaysian Army to operate a short-range battlefield UAV for surveillance mission. The UAV must carry a camera suited to observe battlefield at altitude of 1,000 to 3,000 feet above ground level. So this is not a high altitude UAV, so it's a low altitude. Okay, 1,000, 3,000 feet ni dia tak dah tinggi tapi tak dah rendah sangat. So minimum dia 1,000 kaki, dia mesti at least naik 1,000 kaki, maksimum 3,000 kaki. So dalam performance you should set a target. Okay, you should set a target that since it must be flying between 1,000 to 3,000 feet doing its job. So sekurang-kurangnya your target should be service ceiling mesti 3,000 kaki. Bukan absolute ceiling. Okay, ingat service ceiling. Service ceiling meaning that the altitude in which your maximum rate of climb is 100 feet per minute ataupun 0.505 meter per second. So meaning that your absolute ceiling should be more than 3,000 feet. That's a challenge, yeah. Okay, for such a small airplane. You are to design an unmanned aerial vehicle to carry the task of surveillance mission. Okay, so this surveillance, okay, mesti bawa kamera. Okay, so launch method dia adalah by hand, meaning that it must be able to fly at low speed. Okay, at low speed. Maknanya you baling pakai tangan, dia dah boleh terapung dan dia dah boleh terbang. So dalam case macam ni, usually if we were to design the UAV about this size, this method of launch, you must have a weight yang suitable, extremely low weight, but at the same time wing dia cukup besar, wing area dia cukup besar to permit, okay, launching speed yang agak rendah. Okay, now UAV mass is given to be not more than 2 kg. That should also include the weight of your camera. Okay, the weight of the camera included, not more than 2 kg. So imagine this, you kena baling something yang maximum dia 2 kilo and probably the minimum speed for that aircraft probably should be around 30 to 40 km per hour. Okay, I think to be safe, you can safely launch something tanpa perlu berlari dan membaling macam orang baling lembing. Okay, tanpa perlu buat macam tu, you boleh baling selamba je macam tu. Probably you should target the speed to be around 10 meter per second. Okay, 10 meter per second. Now, at what angle of attack? You have to think about the angle of attack for launching. You cannot launch an aircraft at its maximum angle of attack dengan tangan, because how do you know if you want to launch it at maximum angle of attack? Let's say your maximum angle of attack is 15 degrees. Macam mana you baling Then you make sure dia 15 degree. Usually you akan baling dia straight dia macam tu. That will be around maybe very small angle of attack around 3 to 5 degrees. Okay, that's the sort of thing that you can set on the wing. So usually you set your wing to be around 3 to 5 degrees. Okay, and that should correspond to the angle, angle of attack of the wing and the CL of the wing. Okay, and that CL of the wing should be around between 0.3, 0.4 to 0.5. Okay, so let's say you use an airfoil, and when you set at 3 degrees angle of attack, it will give you around 0.4 CL, value of CL. So you have to set CL 0.4, okay, set CL 0.4, and kemudiannya you set wing launching speed 10 meter per second at sea level. So you use air density of sea level, and from there you know the weight of your aircraft is 2 kilogram, and from there you can calculate the V, the velocity, the launching speed. So that's the speed, 10 meter per second. And usually it is also meaning that your stall speed is much lower than that. But you have to launch not at its maximum angle of attack. You have to launch it at the angle of attack that is comfortable for you, for it to fly. Okay. So meaning that uh, if you work on it, you may find that your wing could be a little big. So let me demonstrate. Kita guna Excel, tak susah kan? So you have mass of the aircraft, okay, kg 2. Okay, I'm gonna make this besar sikit. So mass of the aircraft 2 kg. Um, launching speed kita you set launching speed 10 meter per second. Okay. So apa lagi yang kita target? So air density rho kilogram per meter cube. Okay. So 1.225. Now this is 1.225. This is ideal condition at sea level. So but you have to launch this at a realistic new condition, which is usually this is the air density di Malaysia 1.15 at sea level. Okay. Tapi kalau nak buat performance punya evaluation later on, you boleh pakai ISA. But now this is air density at sea level. Okay. Now let's say your target launching CL would be around 0.4. Okay. So from there you can calculate what is your wing area. The target is to find the wing area. So wing area is it should be the weight of the aircraft. Okay, weight. Okay, which is mass times 9.81 divided by half air density rho velocity squared as ada CL. So this is the wing area that is needed. Besar oh. Ini sangat besar. Okay. Ini sangat besar. So it's not that easy. So you have to, uh, perhaps if you target your CL to be much lower than 0.4, you need bigger wing. So probably you can set your wing to be angled a little bit more, so that bila you baling, you can target your CL to be around 0.5, and that will give you wing area of 0.682. Okay. meters squared, and that is still huge. Okay, it's a huge size of wing. Now, assume that the wing is bentuk kotak empat segi like this. Let's say this is your wing. Okay, this is your wing. Warna putih, line color hitam. Okay, this is your wing. Okay, ini body. Tak apalah, doesn't matter. But ini wingspan B and yang ni chord. Okay, so imagine wing ni should be panjang lah. Okay, so chord wingspan. Okay, chord C, wingspan B. Now you can play around the shape. You boleh buat wing dia supaya ada uh, bentuk macam trapezium ke apa ke. Tapi kita start dengan wing yang straight dulu. Okay, start dengan straight wing dulu.
Doktor?
Ya.
Yeah. Untuk kelas hari ni ada screen recording ke?
Tak ada.
Tak ada. Okay.
Tak ada. You have to be here.
Alright. Yes.
Okay. So you have to ask question. Tak ada masa untuk absorb lagi lah. Okay. So this is your chord. Okay. Now you can play around with the chord and calculate the span. Sebab simple je kan. Wing area bahagi dengan chord you dapat wingspan. Atau wing area bahagi dengan wingspan you dapat chord. Whichever that is possible lah. Okay. If you look at this, dia tak letak limitation kepada wingspan. Tak ada. And dia tak ada letak limitation pada chord. Meaning that you should find the size of the wing. Okay. Just to look at it lah. So let's say chord kita set pada 0.3 macam tu. Set pada 0.3 and then this one divided by 0.3 wing area. This is the wingspan yang diperlukan. Okay. So 2.2 meter which is actually manageable. Okay. Untuk army bawa lah. Dalam 2 meter, 2.2 meter lebih kurang panjang tinggi pintu. You should be alright. Okay. But ingat wing dia agak besar sebenarnya. Okay. So ini agak besar and you kena ingat dia 2 kilo. Okay, 2 kilo. Tapi ini yang banyak. Saya tak tahu apa sebesar ini wing dia. Macam mana you nak buat supaya 2 kilo. Meaning that when you look at this, you have to consider the material also. The material of the aircraft. Okay. So launching speed 10 meter per second probably a little bit too low. Okay. Too low. But it makes sense. Yeah. It makes sense. Probably you want to launch a little bit faster. Let's say you make it 12. Okay, 12. And your chord is 0.3 and your wingspan now it's reduced to only 1.5 or 1.6. So beza sikit je launching speed. Okay. So to get 12 meter per second a little bit some effort is needed lah. Tapi another way of doing is okay. Instead of you calculate the span, okay, you set the span sebagai limitation. So I don't want say you feel that you don't want the aircraft to be more than 2 meters, so it's not going to be too big. So you say you set the 1.8 meter, then you play around with the chord, okay, which is S divided by 1.8. Okay, so that's your chord. Okay. So you play around with the chord. Instead you play around, you set a limitation to the wingspan, because wingspan akan actually affect of macam mana army ataupun seseorang tu dia nak bawa. Kalau wing terlampau panjang, okay, dia nak kena masuk dalam dia punya rucksack dia, kan, dia nak kena bawa benda tu, and your enemy will know, dia akan, you ada bawa UAV. Kalau dia tengok bag tu, ataupun dia tengok orang tu bawa equipment terlalu besar, so benda ni nak kena dibawa, diangkat. Okay. 2 kilo tak berat mana, tapi dia bulky. So you need to consider maximum span. Okay. So if you set that, so your launching speed to be around 12 meter per second with R 1.15, your CL around 0.5, then you can okay. And 0.5 value of CL is usually correspond to the maximum lift to drag ratio. Okay, correspond to the maximum lift to drag ratio. Selalunya kalau kita calculate L over D, you will find that its optimum L over D is around 0.5. But that is not the value of CL that will give propeller aircraft its endurance. No, that will only give a propeller aircraft its maximum range. So if you're talking about endurance, it is CL kuasa 3 per 2 over CD. Okay. So if your CL over CD max is around 0.5, it's usually CL kuasa 3 per 2 over CD uh, should be around okay, ada certain value. Okay. Yang ini sebenarnya senang to comprehend. If you set your CL optimum around 0.5, that will give you CL over CD max of 0.5. Okay. And you boleh tengok daripada based on this design, you can just calculate the aspect ratio. AR aspect ratio adalah span bagi dengan chord. Aspect ratio 6.83. Okay. Ataupun 6.84 or something like that. So dari situ you need to calculate what is your, kita nak cari CD. Let's say you can estimate your CD naught. You punya kapal terbang conventional, your CD naught should be around 0.02, for example. Tapi sebab dia kecil dan dia ada ada apa? You ada control surface, control punya rod terkeluar daripada situ, katalah 0.025. Okay, CD naught 0.025. Okay, so based on this, actually your CD optimum will be 2 kali ganda CD naught atau 0.05. Okay, tapi tak apa, kita letak K. K which is actually 1 over pi E aspect ratio. Okay, so we assume that it's 1 over pi, kita pi lah. Okay, E kita assume dia 0.8, aspect ratio ini 6.84. That's the value of K. Okay, it's a value of K. So from here we can estimate the CD optimum, okay, which is basically 2 kali CD naught 0.05, CL optimum, okay, which is basically square root of K over CD naught. Okay, kalau saya ingat saya pernah lupa, tapi tak apa, square root K bahagi dengan CD naught. Okay. Oh, ini salah. CD naught over K. Okay. So this is your CL optimum. Okay. And that will give you lift to drag ratio around CL optimum bahagi dengan CD optimum 13.1, which is very comfortable. So good. Okay, very comfortable. So if this is your case, then you can launch the aircraft at the CL optimum of 0.655. Okay, so meaning that you have to aspect ratio as kita boleh set CL ni. Okay, CL launch sama dengan optimum dia. Okay, sebab dia launch dia terus cruise and climb. Okay, so you set this to be 0.655. Oh, tak boleh it's in a loop. Okay, tak boleh. So tak boleh. 655. We need to type manually. Okay, type manually. Now, bila you tukar CL optimum dekat sini, your wing area pun berubah. Okay, sebab dia bergantung pada CL optimum yang kita set. Okay, so dia akan berubah and dia akan mengubah aspect ratio, akan ubah chord, akan ubah aspect ratio. Okay, and bila aspect ratio berubah, ia akan ubah nilai K and also dia akan ubah nilai CL optimum dia lagi sekali. Okay, now sekarang you have to do, what you need to do is to find where all these agree, value ni sama. Letak 0.75 kat sini, dia akan ubah lagi. Okay, so meaning that to make sure benda ni sama, and if you look at this, you want L over D to be as high as possible, meaning that your span you dah set, so meaning chord to be as the smallest possible. Okay, the smallest possible, meaning that your CL mesti besar, optimum CL ni mesti besar. Okay, so to get a high optimum CL, meaning that you need to set it at angle of attack yang sesuai dengan dia punya ni. Okay, so if you set let's say 0.75 kat sini, ini jadi 0.83, so doesn't make sense. Okay, doesn't make sense, meaning that kena ada adjustment to the wing area. Okay, so that it will give you 0.75 kat sini. Okay, so you need to adjust the launching speed for okay, so you nampak 0.669 kalau itu tukar we launch jadi 10. So it should be, kalau 12 tadi dia akan jadi 0.8. So what we target is 0.75 for example. So it should be between 10 to 12. Let's say we put in 11, okay, it's 0.73. So meaning you should be slightly higher than 11, let's say 11.2, dapat 0.749. Okay, so probably 0.25, 53 sangat. Okay, 751, 21. Okay, so launching speed should be around 11.21 meter per second. Okay, dengan air density 1.15, your CL launching is 0.75. Okay, so this is what you set. You want to set your launching CL 0.75. Okay, maknanya you punya wing tu dah ada siap-siap angle of attack dia dah set. So 0.75 selalunya kalau wing ni lurus, aspect ratio dia tinggi pula tu 8.9, meaning that wing tu dia dah angle up dalam probably 9 degree macam tu. Okay, so selalunya dia untuk airfoil dia punya nilai CL dia bertambah 0.1 bagi setiap 1 degree angle of attack. Jadi kalau CL not selalu dalam 0.2. Maknanya CL at 0 angle of attack 0.2. Kalau dekat 3 degree dia 0.5. Okay, 3 degree 0.5 0.5. Jadi kalau you nak 0.75, probably dalam angle of attack dalam 5 ke 6 degree macam tu. Okay, so 5 to 6 degree angle of attack. So it should be comfortable if you have this 0.75. Okay, So that's the wing area sepatutnya 0.362. Okay, this is how we want to optimize ya. Okay, just your wing chord 0.2, wingspan 1.8. Actually sebenarnya ini kalau you perhatikan unit UAV memang inilah size dia. If you want to fly with more than less than 2 kilogram wings berat dia, inilah optimum dia. Kalau you tengok aspect ratio should be around 8 to 9 or 10 probably. Kan? Maximum kalau 10 meaning that your wingspan is 1.8. This is the case where you set your wingspan to be 1.8 meter, which is around 6 kaki lah. Okay. So, jadi chord dia 0.2, 20 cm. So, tak terlalu tebal. Okay. Tak terlalu tebal. Lebih kurang lebar size A4. Okay. A4 paper. Macam tu. Bukan panjang A4. Panjang A4 paper lebih kurang 30 cm. Something it's less. Dia punya lebar ni dalam 20 cm. Okay. So, around lebar yang A4 paper. So, your CD not ni 0.2, 0.25. This is what you set. Okay, so optimum CD 0.05 and optimum CL 0.75. So you get LOD around dalam 15. Maximum lift to drag ratio. Okay, ataupun max Optimum LOD ataupun maximum lift drag ratio dalam 15. Which is good, comfortable. Now, uh, if you assuming that your launching speed is the same as your cruising speed ataupun cruising untuk range. Okay. Sebab dalam kes macam ni, kapal terbang macam ni antara um, cruising speed untuk dia terbang sekejap excuse me, ada call. Okay, sorry, minta maaf, ada gangguan. Okay, so
Okay.
again now kita dah ada basic parameter data dia untuk apa yang kita nak design pada kapal terbang ni sekarang. Okay, so this is based on assumption that the launching speed also happen to be the optimum speed because can no point lah you kena buat setting lain kan. So meaning that kalau dia optimum speed dia ialah 11.21 meter per second, it can actually fly even slower than that. Okay, stall speed dia mesti lagi rendah. Okay, mesti lagi rendah. Okay, now this you dah ada baseline dia, so that's not a problem if you were to design in open BSP kan. You just take the wing. Okay, and you look at the plan, you bagi wingspan 1.8 meter. Okay, and chord you 0.2. Okay, so wing area 0.36, which is yep, around that. Okay, so that's your wing. Okay, so ambil wing straight je 0.2, peak dia pun 0.2. Okay, so ini your baseline wing. Okay, that should be your baseline wing. But of course I believe so. You kata I want to make it more cantik ke apa ke, you can do that also. Tak ada. As long as you can set your okay. If you look at this wing geometry, ini span you dah fix je. Half span ni 0.9. Okay. You can play around with root ataupun you just set area dia must be this, span dia must be this, tak boleh average chord 0.2. Okay, so area you fix, wingspan you fix, you play around with the root. Okay. So let's say you nak 0.3 root dia. Tapi average chord mesti 0.2. So wing jadi macam tu lah. Okay. So dia akan automatically adjust the tip to be less. Actually this is too much. Just 0.25 little bit. So probably you lose, make sense. Okay. Now, apa reason dia orang buat tapering pada wing ni ialah untuk mengurangkan wing loading dekat ujung. Sebab kalau wing load dia sama je ujung ke ujung, dia akan cause moment yang besar pada stress pada structure dekat dalam. So, sebab kat luar ni besar force dia. Sama besar dengan kat dalam, kat tengah. Tapi bila kita buat tapering, force kat ujung ni dah kecil sikit. So moment dia tak besar, caused by force kat sini. But moment kat sini lebih besar. Force dekat wing root lebih besar, tapi moment dia kosong lah. Okay, moment tak ada. Sebab dia duduk tengah-tengah. So bending moment. So in term of structure is better. In term of structure. Okay, but many will argue that this is only 11 meter per second square. Wing load dia sangatlah rendah. So probably you want to scoff that. Just leave it with the straight wing. Okay. Sebab reason dia memudahkan construction. Okay. Now, let's look at the airfoil selection. Okay. To fly this low, you need an airfoil that is highly cambered. And thick airfoil. Okay. Probably around 15% thickness, maximum thickness ratio. T over C around 15%. And you want it to camber around 4% instead of 2. Okay. So if it's camber around 4%, I'm gonna make it transparent. Okay. So look at this. So high cambered near wing. So 15% thickness, 4% camber, maximum camber location dia dekat 40%, for example. So nampak begitu camber, begitu bengkoknya wing tu. Okay. You boleh buat wing yang lebih bengkok lagi. Making it only 12%. Lebih bengkok lagi. Okay. Ataupun 10% lagi bengkok. Okay. So either that, semua okay. 15% maybe a little bit too thick kan. So you say 12. That will give you F4 series number ni Naka 4412. Okay, 12%. Or you boleh cari 4410 nipis. Okay. So why nak nipis? Kita nak dia material kurang kan. Okay, let's say 4412 lah, because you ada data aerodynamic about it, because you don't want to be using airfoil yang pelik. So I just copy, just go to the next airfoil, the tip airfoil dia, I just paste. Okay. So see airfoil. Okay. Cuma 12, so 4 macam ni. Okay. Kenapa pula airfoil dia terbalik? Alright. Okay. So that's your wing. Okay. You boleh garnish dia kalau you nak dengan tip cap. Okay. Root cap dengan tip cap dia, tip dia you boleh buat dia round. Probably twice the length. So you tengok dari atas, at least ada bahagian ni. Now this tip cap is very important to reduce the trailing edge vortex. Dia ada tornado yang kat ujung ni. Okay. Okay, tornado yang kat ujung. So the more you have this, doesn't mean it's better, tapi at least ada sikit. Okay, at least ada sikit. Now you have your wing here. Okay, you already have your wing. The sizing yang betul. Okay, sizing yang betul. Just keep it simple. Try to keep it simple, the design. Most importantly, it must be make sense. Okay, now that brings us to the size of the body. If you look at the requirement for your mini project, okay, it propulsion electric, so it's gonna make your life easy. Okay, banyak electric motor yang kita boleh pilih. Radio communication range 10 km. The endurance is 1 hour. Okay, you have 1 hour endurance. So you need to fly endurance of 1 jam. Okay, dia kata loitering speed not more than 60 km per hour, but we have set it to be around 11.1 to 11.21 meter per second, which is 3.6, 40 km sejam. Safe. Okay, safe. So the launching speed dengan cruising speed is more or less the same. So 40 km sejam. Okay. So ni dalam 40 km sejam. 60 km sejam, 60 meter per second, 60 km per hour, we should be around 60 lebih lah sikit. Sorry, 15 macam tu. 15-16 meter per second. Now that you have set your wing right, you need to find some information about what would be the suitable size, suitable battery. Battery besar mana yang kena bawa? Electric motor senang. Okay. But the thing is you need to set juga macam mana dia punya configuration of the wing. Okay. So my suggestion is to have the body to be as simple as possible. Okay. To be as simple as possible. So I think the most aerodynamic body that you can have, okay, just take, of course you can take a fuselage, but you have to draw the fuselage one by one. Okay, it's a good skill. You boleh design fuselage sesimpel yang mungkin. Okay, but bentuk yang paling aerodynamic probably bentuk yang kita panggil dia, mana tak ada ni, hinge, ellipsoid blank stack wing fuselage pod. Okay, you can have this pod. Okay. So, rule of thumb, wingspan 1.8 untuk design wing yang agak slow macam ni. Body dia takkanlah 1 meter je. Probably body dia, you boleh start dengan 1.8 juga. Start with the body at 1.8. Okay. And if you look at this, besarnya body dia. Okay, because it's fine ratio dia tak betul. So, you can increase the fine ratio to 20 probably. And reposition the body. I would like you to have your zero position in the leading edge of the wing rather than nose of the body. So body ni you kena ke belakang sikit lah kan, 0.5 macam tu. Okay. Now, if you feel that the body ini panjang sangat body ni, 1.8 meter nak bawa macam mana? Okay. So you can reduce to only 1.5 meter. The same fine ratio. Now, problem is the fine ratio ni adalah satu nilai yang mana lagi besar nilai dia, lagi slim body dia macam tu. Dia 25, lagi slim lah body dia. So you not be able to control. Aku tak tahu nak control dia berapa besar. So you don't like it, you just delete. You ambil fuselage, just add position dengan fuselage dia lebih kurang 0.5 meter in front. Okay, sorry, negative. Okay, in front, and you start with the design of 1.5 meter. Contoh. Ini yang susah sikit ni, jadi macam ni pula kenapa kan. Okay. Oh, salah fuselage ambil. Kita ambil fuselage ini. Transport fuselage. Okay. Sebab ini dah ada design. 1.5 meter. Okay. Diameter dia. This is what you can control. So, agak-agak berapa besar dia kalau you boleh pegang dia comfortably. Kan? Berapa besar dia. And you can place your computer and camera comfortably inside your battery inside. So you need to some experience on this. You need to anggarkan what will be the size of the battery. So if you're planning to fly an aircraft that slow, probably you need a battery yang lebih kurang 12 volt atau 11.1 volt, 3 cell. Probably the thickness will be around, okay, the thickness will be around 3 centimeter. Okay, so let's say diameter yang you comfortable pegang adalah lebih kurang 10 cm atau 0.1. That should be the diameter of it. Okay. Atau untuk yang tangan lebih besar mungkin probably kena ingatlah benda ni dia bulat kan. Body dia bulat. Jadi kalau 10 cm diameter meaning that item kat dalam tu mungkin comfortably tak boleh lebih lebar daripada 0.7 kali 0.7. Itu pun kalau skin dia senipis kulit bawang. Okay. 0.7 kali 0.7. Kalau benda dia punya tu part segi sama, dalam dia 0.7 kali 0.7. Itu paling lebar dia boleh letak. Okay. Kalau dah sebab benda ni body dia bulat. Okay. So let's say lah 0.7 that's big enough for you. Alright. So you tak diameter dia 0.1. So that's your, okay. So you want to put it relative to it, so around 0.5 is negative. Okay. Somewhere around macam tu. Okay. Probably nak letak wing di atas. Let's say you turunkan body dia 0. Sebab dia 0.1, so 0.25. Negative 0.05. Okay. So letak wing di atas badan macam tu. Okay. Nanti boleh modify wing dia jadi persegi ke what not. Okay. So most payload dia akan letak dekat depan ni. So untuk kapal terbang macam ni, probably sebenarnya you put a battery apa semua dekat depan, kamera kat depan, motor kat depan. Okay. So if you think that 0.1.5 meter is too long, you can shorten to only 1.2. Okay. Pendek kan? And yeah. Okay. So you can have your battery somewhere here, your camera maybe below, and your motor kat depan, your system ke apa ke, semua kat sini. Whatever belakang ni is not useful. Really you letak antenna saja. Okay. So you have to think about it, benda ni, system. So you can start playing with the off center. Okay. Set 0 dulu. Okay, dia tengok tengah-tengah. Okay. Outfit ni apa dia buat, lebar dia. Okay. Off height ni berapa tinggi dia. So play around with this. So if I were to set all the way up to the wing like this, okay, like this. Sebab bahagian yang kita nak letak ni mesti depan daripada wing. Whatever you put it there lah. Okay, as for nose, probably not planning to have any nose yang muncung tajam tu because you need to put the electric motor in front. Okay, so just that's it. Okay, so you just set nanti you letak electric motor there and everything. So kalau you rasa nak letak tail tinggi sikit, okay, just play around with the height with naikkan, okay, naikkan, there you go. So this time you're gonna have you nak tebal lagi pun boleh. Okay. So whatever it is doesn't matter lah. It's up to you. Okay. But there must be a reason for it lah. Okay. Now you have this. Abang adik keluar. Keluar. Okay. Now you have this part. Okay. Now I would recommend you to go and set this to be transparent instead of default. Set it to the glass slide. Okay. Why? Because you need to put things inside. Okay. You need to imagine things inside. Okay. Not kita tak lukis lagi pasal dia punya tail dia apa lagi, belum lagi. Okay. You need to put things inside. So, for example, now this is transport switch. So, letak box dia dulu. Okay, letak box. Add a box. Okay. Let's say your battery 3 cm 0.003. Panjang dia kata bateri tu panjang dia 15 cm. Okay. 0.15. Okay. The width is 3 cm. And the height pun sama 0.03. Okay. So that's the size of the battery. Okay. Selalunya width dia lebar sikit. So 0.5 tu. Okay. So that's the size of the battery. Okay. That is the size of battery 3 cell yang give you around 15,000 milliampere hour. Okay, you can have a bigger battery. Sorry, 5,000 milliampere hour. You can have a battery that's 20 centimeter battery, misal sikit. Okay, put it there, or you relocate dia. Okay, relocate dia letak kat dalam. Okay, let's say that battery ni bagi color blue. Okay, so that's your battery. Now, adakah betul-betul letak dekat bawah wing? Tak, dekat bawah wing ni akan ada support structure untuk dia. Okay, so most likely your battery have to be in front. Okay, probably there. Okay, dekat dengan electric motor kat dalam, kat depan. Okay, electric motor. So you can put your, ni just imagine ya, tanpa sizing yang proper lagi. You put in propeller. Okay, design of the propeller probably around 10 inci katakan. So it's going to be 0.25 in diameter. Okay, number of blade 3, whatever you can have. Okay, just position dia baik and put it at minus 0.22. Sorry, 0.3. Okay, somewhere kat depan. Okay, now this is assuming that your electric motor dia duduk dalam lah, contoh. Okay, and you look at it, probably kecil sangat. So, you buat satu kaki punya motor elektrik. Okay. So, 2 blade. Okay. So, okay. So, imagine this is your electric vehicle. Okay. 1 inci propeller, that's it. Okay. Now, so battery kat dalam tu, you need to do some study. Okay. What would be a camera yang you nak bawa? Okay. So, Ada macam-macam jenis, ada macam-macam size. You want it to be small as possible. If you look at this UAV Talon, it's a 1.8 meter wingspan retail UAV. It's around the size you have. Okay. You may want to study what kind of camera yang dia bawa. Now, in this case, you're going to put the camera in front. Your propeller di dekat belakang. You can also design it to be like this. Okay. It's up to you. Okay. But again, you must justify why. Okay. So, in this case, I'm going to put camera to be looking downward. Okay. It's much easier for us kan untuk letak kan. Just malas nak letak ada box. Kali ni kamera warna hitam, black. Okay. So size of the camera will be around 3 cm panjang, lebar dia 0.02 on that size. Kecil je kamera dia. Okay. So bawah lagi kita pusingkan dia minus 90 degrees. Okay, dia menghadap ke bawah. Untuk okay. So since we set our CG somewhere at the datum of the wing, I think probably good if you put near the CG because kat situ will be the center of rotation dia. Okay. So probably the center of rotation of the camera. Okay. Kamera ni paling besar macam ni, menghadap ke bawah. Memang ada jual kamera ni, kecil je. Besar macam tu. Okay. Tapi ini tak masuk dia punya flight controller dia lagi kan. So let's say you ada battery and ni ada flight controller. Now, location of the battery ni macam tak. Rename the battery. Okay. Now, battery ni agak sensitif dengan location battery ni agak sensitif dengan CG. So, the best possible way is to have a battery ruang seluas-luas dia untuk jadi since kamera ni kena giveaway lah. Kamera ni I think battery letak belakang. Okay. Tak belakang. 0.2. 0.2. Belakang ni depan sikit lah. You put the camera there. Kat situ. Okay. So because I want to remove a battery, we'll put the battery to be the closest possible to the center of gravity. Okay. Balance out the aircraft. So that's where you put your battery. Okay. So sekarang we add, let's say, flight controller, flight computer. Okay. Just slightly shorter there. Lebar lebih kurang. Okay. Kita letak warna merah. Okay. Selalunya dia duduk atas. And depan. See, senang nak masuk bateri, tak flight controller, nampaknya flight controller ni macam dah terkeluar. Seorang sikit. Seorang. Okay. So ada flight controller dia, ada satu. And ada ESC, electronic speed controller. Selalunya dia duduk somewhere between motor dan bateri. Okay. Letak dekat situ. Contoh electronic speed controller. Tukarlah flight controller kita buat warna hijau. Ada green default. Okay, that's a flight controller. Okay. So flight controller, electronic speed controller, your motor saya tak lukis but somewhere around there. Your battery. So that's your camera. Your camera probably need another chip. Okay, kita panggil dia OSD. It can be integrated with flight controller ataupun you just have another chip that is half the size of the flight controller. You just put it there behind the camera. Okay, so small is what the size. Okay, so this ruang ni, you imagine ini ruang untuk bateri ni besar. This allow you to have another battery, at least 2. Okay, so if you want to increase you punya capacity, but remember you are limited to only 2 kilograms. Jadi if you look at this, it is clearly seen that you can optimize lagi the size of the body. Boleh buat kecil. And body you tak semestinya bulat. Body you boleh buat 4 segi. It's up to you. You boleh design body dia 4 segi. Ngam-ngam je letak everything. And then you tak semestinya kena ada body belakang yang bentuk aerodynamic macam ni. You can have a body 4 segi di depan yang fit everything snugly, nicely fit in. And then untuk sambung ke tail belakang, you just need a carbon fiber rod bulat sampai belakang, sambung dengan tail. You can always do that. Okay. So ada soalan? I nak stop kat sini. Meaning that give you a teaser thinking process, design thinking process. Okay. So the reason kenapa saya sampaikan benda ni, because actually sebenarnya sekarang is apa kaitannya design pesawat dengan flight performance? Mainly because of aircraft design and flight performance is very much related. Selalunya bila orang design aircraft, he or she wanted to also start with flight performance dulu, because kita design kapal terbang to achieve performance objective. Then once the performance is objective kita dah capai, and then after that kita buat detail design untuk determine you punya stability, okay, structure design dia macam mana, all the system macam mana. But even at this preliminary punya design, which is basically this is preliminary stage, okay, you have to since kita ada computer aided design yang sangat senang, dia lebih mudah daripada CAD yang gunakan Katia tu. Kita ada vehicle sketchpad, it actually help you to put things into something that you can see clearly. Okay, now if you look at this, apa benda yang lain-lain yang kita hitam ni, sorry, tak present. Okay, just to share that kalau ada nampak line hitam ni besar macam ni, you boleh redesign, you boleh design dia dalam milimeter, tapi saya buat ni dalam meter sebab senang. Okay, benda ni actually shows you punya direction of rotation of your propeller. Okay, and that gives you thrust ke depan arah sini. Okay, that's all. Itu je dia tunjuk. So jangan pening lah, ni benda apa ni kan, selirat ni. Okay, tapi yelah kadang-kadang you can get annoying this line. Okay, so I pun tak tahu macam mana nak hilangkan dia, but it's okay lah. Okay. So later on saya akan sambung cerita pasal 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 benda lain lah. But sekarang for now ada soalan tak?